how did it go? Um, uh, okay, I will go through this. Actually, my question is a little confusing. It's incomplete. So I didn't provide enough information for you to finish the variance and the standard deviation. I apologize for that. And you will see. So for mean, that you think is clear for you, right? Add them up and divided by 7. So right, that's a little confusing. Now some students will say there's a reason. Later there's a reason. There's a difference. Divided by 7 or divided by 6. There's a difference. And I didn't make my question clear. Right now, for calculating mean, no confusing. You add them 4 plus 6 plus 9 plus 2 plus 5 plus 13 plus 3. And you add up is 42. Is 42. Divided by 7 is 6. This is the mean. However, we shouldn't be professional. For the mean, there are 2 symbols. One symbol is another symbol, a different meaning is a mu. And which is which, the here will be different. This means these numbers are a sample from out of a population. These numbers are representing a lot more numbers. These numbers were selected out of more numbers. These are samples. If these are samples, then this is X bar. And it is a 6. The mean is a 6. If these are not representative, are not samples, that's all. For example, let's say there are only 6 pandas left in the world. There are only 7 pandas left on the world. There are not, say, millions of animals, and we randomly we catch the 7, and these 7 are we try to study this sample to know about all those in the wild. Let's say this is all the population. This is everything. We only have 7 pandas, 7 animals. So these are populations, they are not samples. Then this is the mu. I'm sorry, that's no problem. Mu. This is the population mean. This is a sample mean. This is a population mean. It is on your board, chapter 12. Is that on? I'm sure it is. Okay, the mean. Now for the median, we jump to here. How to find the median? How to find the median? So I just sorted, okay? This is a scratch paper. Let's say this is a scratch paper. Is that it? So what's the smallest number? 2. And what's next? 3, 4, 4.
5, 6,
Huh?
9,
9, 13. And we have totally have 7 numbers. And so the middle one, the middle number, median is a 5. Okay. The advantage again, if this becomes very small, this becomes -2. It's still 5. But this will be changed. This will be changed. Okay. So this is the median. The median, there's no symbol. There's no it's just a median. Most of the time they use English. Median. Okay. Median. Is 5. The mean is a 6. The median is a 5. And now we move on to the variance. It is on your, the formula is on your textbook. The formula is on your textbook. I need to erase this because you can do this when you were this much, right? So I don't need to keep it. I don't need to keep it. So we calculate the distance. Each number, the distance, we know is the mean is a 6. The mean is a 6. The mean is a 6. Let's say here is a 6. Okay. The first number is 4. Okay. We calculated the number, the distance. This number, the distance to that. In purpose, I use a simple number. In purpose for teaching purpose, but in real life, may not be this simple. Okay, but it's the same logic. It's the same logic. It's your number, the distance from your number to that. Okay. And here, because it's on the left, it's a -2. And we don't like that, so we make it a square. We make it a square. So it doesn't matter is on the left or is on the right. So -2 squared is what? Is a 4. This is on your book, okay? Now, this number. This number is right here. The distance between here to the mean is 0. But I still write it down. I still write here. It's 0. Okay. And this number, 9. So the distance from the number to the mean, okay, is 9 minus 6, even though it's a positive 3, but was squared, but then it's a 9. And 2, this one, the distance to the mean, okay, is 2 minus 6 squared. So 2 minus 6 is minus 4. Minus 4 is a 16. Always positive because the square is made this. And the 5, the distance from 5 to 6, and this number, this is very far away. This is very far away. 13, the distance from here to the mean, okay? 13 minus 6. 49. And you can tell the numbers too far away from the mean contributes a lot of variance. Because the distance is long, right? And we even squared. The distance is 7. And by this square, like amplified, 49. That if for biologists, you are doing for biology, you want to study some like the proteins or whatever response. This makes the number and is not consistent. Put it in this way, and it's not too good. That means your number is very jumpy. If the antibodies, if we measure, these days they're always talking about the vaccine, and they inject it and to measure after 2 weeks or 1 month, then to measure the antibodies for the volunteer in the blood. And for biologists, we wish it's like a machine. We wish human body like a machine. Everybody's response is very, very consistent. However, in real life, biology is not mechanics. So this jumping down. This number contributes a lot. Okay, so we can anyway. No matter what, we still. So the distance from here to here is 3, minus 3. But we squared it. So it's not. Okay. I should write this number in blue. And didn't finish variance yet. How to calculate variance? How to calculate variance? How to calculate variance? Add all these numbers up, and what's the total? 88. Thank you. 88. Now the variance, because we still want to do some average out. Otherwise, if we add one sample, if we add one more number, this will be larger. So the 88 needs to be averaged out. Needs to be averaged out. Needs to be averaged out. Here is a tricky part. What's the number here? If these are sample, most of time, they are samples. They are samples. Okay. And so here should be divided by 7 minus 1. 6 is 1 less. This is 1 less. In this world, nobody can explain why I want to make 1 less. MIT professor teaching statistics, MIT, the best professor, he said make a number looks good. Only thing the number looks better, 1 less. So is 1 less will make this number slightly larger. What makes this number slightly larger? And they think divided by 7 is not too accurate. Make 1 less, average out by 1 less. The result is more expressional, can describing these numbers better. That's their feeling. That's their feeling. And this formula is not from me, it's on your book. That baseball superstar here attended 22 seasons. He has 22 numbers. 22 numbers. But when calculating the variance, is divided by 22? 21. Is divided by 21. Okay? And actually, the book could be wrong. Why? Because that's all his numbers is not representing. Maybe he will continue playing. If that's all the numbers he has in his lifetime, he has played 22 seasons. Then that 22 numbers are not a sample. It's a population. That's all his numbers. That's all his numbers. If it is a sample, again, then it's in Excel, tomorrow I will show you, when you select the formula, they have this, VARS and VAR.P. In Excel, when you don't want to do this by hand, these days nobody do do it by hand. But you are teaching, you are student, so you should know it. When you select this, the difference this and this is just one less. It's just one less. You can check. I will take a screenshot of this, and tomorrow we will do it on the Excel, and you will see. If you select .s means a sample is divided by 6. What's the result? What's the result? 14.67. 14.67. And the variance here, they're very important. We cannot skip. The symbol is what? I mentioned yesterday, last class. This means a sample. If it is a population, what's the symbol? If it is a population, it's this. This means a standard deviation. There's a 2 sitting there, 2 on there. Okay? If we are calculating this, then what's the formula? What's the formula? Divided by 7. That's Excel tomorrow, or if you cannot wait, you can do it. Write down this number, you have it on your notebook, you do it on your Excel today. You will see. And this will be some number. 1, 12, 1, 2, 12, 5, okay, 谢谢. So this is slightly larger than this. It's slightly larger than this. The symbols I want to emphasize is important because mathematicians they do not always like me, very talkative. They just give you the symbol. By looking at the symbol, you know what it is. You know what it is. This is a variance, and the unit, because there's a square, so the unit becomes strange. If these numbers are the housing price, let's say US dollar, not $4 to buy a house, don't get it wrong, okay? But it's something maybe 4,000, 6,000, maybe more or less 40,000, 60,000 can buy a house. The dollars, then the unit becomes strange. The unit is a dollar squared. Dollar squared. Dollar squared. This is a natural. This is a natural. Then this one is waiting to solve this problem. Standard deviation. What is the standard deviation? Out of this, what is the standard deviation? The symbol is this for sample. The symbol is this for sample. What's the formula? Yes. You take a square root. You take a square root. You take a square root of the variance. Right now, it's not involved this average, one less or not one less. You just do this, okay? And number? What's the number?
3.8.
Huh?
3.8.
3.8. And if it's a population, not a sample, then that's 12. Okay. Here's one now. What's the number? What's the number? Oh, you do it. Okay, I don't wait. Okay? Huh? 3.5. 谢谢. So, for the, if it's a population, they make this more quiet. That makes this less noisy. For sample, this is more noisy. The standard deviation. Some people call it error. Error. You heard of it. Error. Now the unit is right. The unit is right. Now you take the square root of this and you get this. You take the square root of this, you get this. Chapter 12. This is the second part of chapter 12. Sorry. So, on page 250, there is a lot. How many numbers he has? That is example 4, 22 numbers. You see that squared distance from mean. Do you see that? Remember bring textbook, okay? Remember bring textbook. If you forgot, give me money, okay? I use money to buy candy for you. You don't eat candy? Anyway, let's move on, okay? Did you get it right? Prince, did you get it right? You all did? Square the distance from mean. Square the distance from mean. My number is much smaller than the book. The book number is not bad. It's a very simple number. For teaching purpose, we always use the simple numbers. But you need to really understand. So when the numbers are really messy, you are not be confused. You are not be confused. Square the distance and divided by, if it is a sample, then it's one less. And they should, so on page 251, on the first paragraph, spreadsheet or other software to find x bar and s. The mean is x bar. The mean is x bar. He is talking about as a sample. He's talking about a sample. If it's not sample, then it's mean. If it's a population, then it's mean. Most of the time, we are just select some people or some animal or something. We select some products to study it, trying to find out if every product is so and so. So, page 251. It is usual for good but somewhat technical reasons to average the squared distance by dividing their total by n minus 1 rather than by n. Rather than by n. Many calculators have two standard deviation buttons, giving you a choice between dividing by n or dividing by n minus 1. On Excel, this you will see, you have this to give you the variance sample population. And you will see STD standard deviation S. On Excel, if you select this, it will you not even realize what Excel is doing. Excel, if you select the dot S, and they did this first for you without showing you, then did this square. So if you select this function and select this range, this number will pop up. This number will pop up. And people don't even care what is going on. If you select this and select these numbers, the Excel will do this for you, do this for you, and do this for you, and this 3.5 will pop up. Okay, we can take the demo tomorrow. I still have a lot to say.
Now it's like
Okay.